Hi, I'm Amanda Brunel. I'm with WR Systems. I've been with WR for about 1.5 years now. I've been doing model-based systems engineering for 7 years. What got me started with model-based systems engineering was my love for engineering, and there was a research and development project ongoing that was exploring model-based systems engineering, which was kind of in its infancy, really kind of getting going on some more government contracts. We were seeing more and more of it in proposals, and it was something that we were exploring to see if it was going to be worth pursuing. It's a way of viewing a system in its totality. It's a way for engineers to kind of see a system from all different perspectives and really be able to look at design, requirements, interfaces, all of these things in one space, which is not something that they've really been able to do before. So that's kind of exciting. WR Systems is a technology firm with large naval contracts. Right now, WR is ramping up model-based systems engineering efforts on several of our naval contracts. Model-based systems engineering is defined by NCOSE as the formalized application of modeling to support systems requirements, design, analysis, verification, and validation activities beginning in the conceptual design phase and continuing throughout development and later life cycle phases. Essentially, it's a method for performing systems engineering work that would otherwise be done using a traditional text-based approach. There are large differences between a model-based systems engineering approach and a text-based approach. We'll get into some of those differences and explore why those differences are so beneficial to both the engineers as well as the customer. So how and where is MBSE used? MBSE is a robust, efficient, and cost-effective method of using systems engineering. It can be implemented as a systems engineering approach for both new and existing projects that's increasingly employed by both industry and government. It's implemented by a wide range of industries, including manufacturing, aerospace, defense, and automotive. There are some major key advantages to using a model-based systems engineering approach over the traditional text-based approach. Traditional text-based systems documentation can quickly become outdated or inconsistent as requirements and design changes occur. An MBSE model can act as a single source of truth that ensures consistency between the many system perspectives required of a project. Changes are implemented once and then propagated throughout the model. It also provides a streamlined ability to communicate information and relationships both internally and externally between engineers, stakeholders, both internally and as well as the customer. There's also increased alignment between the project team. It provides efficient, cost-effective approach for systems analysis. It enables simulation and analysis of complex system of systems, provides earlier risk identification, and it facilitates a fast feedback cycle for design and requirements changes. MBSE supports fast learning cycles and lends itself well to agile methodologies. The iterative process of MBSE performed over short incremental sprints allows the model to adapt to changing requirements and design. Frequent work product reviews within these sprints helps to identify defects early. The MBSE approach includes analyzing needs, defining requirements, defining a logical architecture, synthesizing allocated architectures, optimizing and evaluating alternatives, validating and verifying the system. Again, this is an iterative process, both in its totality and within each of those approaches. A single source of truth model streamlines reviews and minimizes artifact inconsistencies across the project. Programs within the DoD and NASA are successfully implementing MBSE currently. WR is currently providing MBSE services on several surface ship contracts. Let's go into some of the things that we're doing. Requirements traceability is a huge benefit of MBSE. Within the model, you can maintain your requirements as well as create relationships between those requirements and system elements. In doing so, you can show full requirements traceability and verification of requirements coverage through your system design. You also have the ability to quickly and easily show system, subsystem, and component hierarchy through the use of block definition diagrams and internal block diagrams. Interface diagrams give you the ability to see how data and control flows both within the system and externally to and from the system. Behavioral diagrams allow users to see how the system interacts with system users as well as how internal components react to stimulus. With requirements traceability, we can take the different sets of requirements that a project has, so top-level requirements, system requirements, subsystem requirements, all the way down to even specific hardware, software requirements. Pull each of those sets of requirements into the model and provide a matrix that maps the top-level requirements to system-level requirements, system-level requirements to subsystem-level requirements. And what you end up with is a matrix that shows that decomposition. That allows you to do a very quick gap analysis where I can see the top-level requirements decomposed into system requirements. And I just look across the top of that matrix and I can see any gaps. What top-level requirements have not been decomposed into system-level requirements? Similarly, are there any system-level requirements that don't map up to a top-level requirement? And why has that system-level requirement been imposed? Is that a mapping that we've missed? Is it a requirement that we've unnecessarily imposed? That type of analysis can be done extremely quickly. And it's that type of analysis that the model really allows us to do much more efficiently than we would be doing in a more text-based approach. One of the other major benefits of using a model-based systems engineering approach is the ability to create ad hoc reports from the model. We use at WR Cameo Systems Modeler. It comes with a myriad of built-in reports that you can use to generate system docs. You can also use VTL to generate your own custom documents. At WR, we've created our own template within Cameo Systems Modeler, added custom code, and we're able to generate cable run sheets directly from our model. Our hardware engineers provided the data on all of the cables in one of our labs. We put that data into the model and we're able to automatically generate almost 300 pages of cable run sheets within a matter of seconds. In doing so, we've saved hundreds of hours of cable run sheet generation time for our engineers. That is just one example of the power of being able to generate documents like that quickly out of the model, again, using our single source of truth. We are able to do that with not just cable run sheets, but also things like design documents, SDDs, SSDDs. This does not mean that we're able to take out the good engineering work that needs to happen as well, but we can generate the core information that would need to populate these documents for our engineers to then go back and put in that analysis that needs to happen. The MBSE approach includes analyzing needs, defining requirements, defining a logical architecture, synthesizing allocated architectures, optimizing and evaluating alternatives, and validating and verifying the system. It's important to remember that this entire process is iterative, both in its totality as well as within each of those steps.